Supernovae. That's when stars explode, right? Well, yes and no. Mostly yes, but there's a lot more to it. Prior to 1985, it was thought that there were two types of supernovae. They were called, funnily enough, Type 1 and Type 2 supernovae. Rudolf Minkowski first characterized them in 1941. So what's their deal? Type 2 supernovae are what most people would describe when asked about exploding stars. At the end of a star's life, it runs out of hydrogen and helium fuel. It starts to fuse heavier elements together, and as it does so, swells into a red giant star. This is the fate of our star, the Sun, in about 5 billion years or so. The Sun will then shrink to become a white dwarf. However, if a star is several times the mass of the Sun, the core collapses in on itself. The implosion bounces off the core, expelling the stellar material out into space. What is left over is an ultra-dense neutron star. If it's rotating rapidly, we call it a pulsar. This type of supernova is also called a core collapse supernova. So what about Type 1? These supernovae are the thermonuclear explosions of white dwarf stars. They occur if the white dwarf is part of a binary star system, and close enough to its companion star that it draws material off the other star. As the extra gas accumulates on the white dwarf, the star becomes more and more compressed. The pressure and temperature rise until eventually a runaway nuclear reaction occurs that leads to a cataclysmic supernova outburst. In the mid-1980s, it was realized that there are actually two more classes of supernovae. The descriptions are the general what happens of Type 1 and Type 2 supernovae, but actually they are classified in terms of their spectra. Type 2 supernovae exhibit hydrogen in their spectra, whilst Type 1 do not. In the mid-80s, the rate of supernova discoveries increased and the quality of the data gathered improved. Type 1 supernovae became further divided into what is now called Type 1a, Type 1b, and Type 1c. Type 1a are the white dwarf thermonuclear explosions. Type 1b and 1c are similar to Type 2 supernovae, in that they are the result of stellar core collapse. Neither type exhibits silicon in their spectra, whereas Type 1a do, but Type 1b exhibit helium, whereas Type 1c don't. It all gets a bit confusing with the traditional naming convention. You would expect all core collapse stars to be classified under the same type designation, but of course this isn't the case. White dwarf explosions result in a Type 1a supernova, and core collapse results in a Type 2, Type 1b, and Type 1c. The supernova in this image is supernova remnant Cassiopeia A, usually referred to as just Cas A. It's the youngest known supernova remnant in the galaxy. So now you have the lowdown on supernovae. Pretty spectacular, hey?
Don't forget to subscribe and like and comment.